In 1897, the Indiana State House of Representatives unanimously passed a bill that would legislate the value of pi. But what did they attempt to legislate the value to? Welcome to part 2 of What's Up with Indiana's Special Value of Pi. In part 1, we looked at the situation of the bill, but didn't look at the bill itself. If you didn't watch that one already, I highly recommend it. It'll put you in the right frame of mind. Okay, the bill was introduced on January 18, 1897, so I won't use any math newer than that. Hint, aside from calling the ratio of the diameter to the circumference pi, which was introduced in 1706, all of the math here is ancient Greek. I will use a modern digital calculator, or rather a software-based calculator on a general-purpose computer, because I'm doing math here, not arithmetic. Okay, so let's dive in. House Bill number 246 starts off with its topic sentence. A bill for an act introducing a new mathematical truth and offered as a contribution to education to be used only by the state of Indiana free of cost by paying any royalties whatever on the same, provided it is accepted and adopted by the official action of the legislature of 1897. Are we excited yet? Section 1. Be it enacted by the General Assembly of the State of Indiana. It has been found that a circular area is to the square on a line equal to the quadrant of the circumference as the area of an equilateral rectangle is to the square on one side. Let's start with the second half of that sentence. An equilateral rectangle means a rectangle with all four sides having equal length. Maybe he was avoiding the phrase, as the area of a square is to the square of one side, using square in both the exponentiation and the geometrical sense. But come on, Doc, just say square. What about the first half? Archimedes tells us in Measurement of the Circle that a circle's area is half the radius times the circumference. Using the knowledge that the circumference is pi times the diameter, and the diameter is twice the radius, we get area equal to half the radius times twice the radius times pi. The 2 and the half cancel each other out, and we are left with area equals pi r squared. Hopefully that sounds familiar. This bill says it's also, or perhaps instead, equal to the square of 1/4 of the circumference. Yes, a more natural way to say that is 1/4 of the circumference squared, but that's ambiguous as to whether the quartering happens before or after the square, and it matters. Assuming we can still call the circumference 2 pi r, that means we need to square pi r over 2. That gives pi squared r squared over 4. If that is equal to pi r squared, it means pi is 4. So yes, that is definitely a new mathematical truth. Section 2 starts off, it is impossible to compute the area of the circle on the diameter as the linear unit without trespassing upon the area outside of the circle to the extent of including 1/5 more area than is contained within the circle's circumference, because the square on the diameter produces the side of a square which equals 9 when the arc of 90 degrees equals 8. I find it interesting how we have moved from quadrant of the circumference to the arc of 90 degrees. When the arc of 90 degrees is 8, the circumference is 32, and the diameter is about 10. Squaring that gives 100 or so, not 9. Squaring the radius is 25 and a bit, not 9. I can't figure out where this 9 comes from. If you understand it, please let me know. Hey there! While editing this, I came up with a theory. The square on the diameter means the diameter squared, and produces the side of a square which equals 9, means that the square root of said squaring is 9. So he's just saying the diameter is 9, but in a whole lot of words. Cool. So 32 over 9 makes pi 3.55 repeating. I knew there was more pi hidden in this bill. Don't like that theory? Have your own? Comment away. Okay, back to the originally intended content. Anyway, assuming it uses linear unit to mean analogous to the side of a square, then I agree. The diameter isn't the linear unit. the radius is, in that the radius doubling is what increases the area by a factor of 4. But maybe I just don't understand the words here. It's not like I have a degree in math. Oh, wait. I actually do. So, it's not like I have a degree in geometry. Yeah, that checks out. We continue, after skipping a sentence that I just don't want to talk about, with furthermore, it has revealed the ratio of the chord and arc of 90 degrees, which is as 7 to 8, and also the ratio of the diagonal in one side of a square, which is as 10 to 7, disclosing the fourth important fact that the ratio of the diameter and circumference is as 5/4 to 4. And because of these facts, and the further fact that the rule in present use fails to work both ways mathematically, it should be discarded as wholly wanting and misleading in its practical applications. First off, good grief, have you never heard of periods? I'm not sure I can get that whole thing out in one breath. I'll try later and put my best attempt here. Furthermore, it has revealed the ratio of the chord and arc of 90 degrees, which is as 7 to 8, and also the ratio of the diagonal in one side of the square, which is as 10 to 7, disclosing the fourth important fact that the ratio of the diameter and the circumference is as 5/4 to 4. And because of these facts and the further fact that the rule in present use fails to work both ways mathematically, it should be discarded as wholly wanting and misleading in its practical applications. Take one! But I can't do voices. Good job, me. Or bad job? I don't actually know. I haven't recorded it yet. Okay. In geometry, a chord is the straight path between 2 points on the arc. Since we all know the shortest distance between any 2 points is a wormhole, I mean a straight line, the chord is therefore the smaller of the two numbers. So, we have a circle. 90 degrees of arc is the same as a quarter of the circumference, and we know that's 8. That means our full circumference is 32. This bill says that the straight distance between the ends of that 90-degree arc is 7. Let's defer now to a different Greek philosopher. The Pythagorean theorem says that a squared plus b squared is c squared for a right triangle. We know that a and b are the same since they're the radius. So 2r squared is equal to 7 squared. Thus, 2r squared is 49, r squared is 24.5, and r is about 4.9497. Doubling that to get the diameter, we have 9.899 and a bit. Assuming the circumference is still pi times the diameter, that gives a value of pi equal to 3.2324 and some change. Using normal pi, by the way, the 90-degree chord of a circle with circumference 32 is about 7.2025, not 7. The ratio of the diagonal in one side of a square is as 10 to 7. So it's quick work with Pythagoras to see that we have a triangle here with sides r, and root 2 times r. So if r is 7, the hypotenuse is root 2 times 7, or that same 9.899 number, not 10. Why is it the same number? Well, if the chord length were 7, then we know the radius to be 7 over root 2. We double that to 2 times 7 over root 2. We remember that by definition of square root, that 2 over root 2 is root 2, and we see that for any circle, the diameter is just root 2 times the 90-degree chord. He's just made us calculate root 2 times 7 twice. 10 over 7 isn't a terrible estimate for root 2. It's only about 1.01% too big. It's like using 22 over 7 as an estimate of pi, which is 0.04% too big. And by comparison, the number we just calculated, 3.2324 and some change, is 2.893% too big. It's about 72 times worse than 22 over 7. It is, in fact, more than 23 pi worse at estimating pi. Back to the bill. Disclosing the fourth important fact that the ratio of the diameter and circumference is as 5/4 to 4. Circumference is pi times diameter, so circumference over diameter is pi. 4 divided by 1.25 is 3.2. That is admittedly a rounding of our previous answer, but this bill did not say it was giving techniques for estimating. It said mathematical truths. So I'm going to call this a third presented value of pi. There are likely more lurking about, which is why I accused the bill of having pi different values of pi in part 1. If you want to dig into the bill and Dr. Goodwin's claims, I have links below. The article in the Indianapolis Journal can be found by going to newspapers.library.in.gov, clicking in the middle of the state on Marion County, scrolling down to and clicking on Indianapolis Journal, selecting February of 1897, picking Sunday the 21st, and going to page 9. It's the center column as well as column 5 and part of 6. I hope you followed the math here. I feel like Matt Parker of Stand Up Maths would do a much better job. So how about it, Matt? It's even more reasons to talk about pi. Now that we've looked at the math in the bill, I'm going to remind you of the reminiscence of Dr. Clarence Abiathar Waldo as published in the Proceedings of the Indiana Academy of Science, 1916. The roll was then called, and the bill passed its third and final reading in the lower house. A member then showed the writer a copy of the bill just passed and asked him if he would like an introduction to the learned doctor, its author. He declined the courtesy with thanks, remarking that he was acquainted with as many crazy people as he cared to know. That's it for this one. I'll see you next time for a regular simple question and simple response.